Hello, I'm Leeman Baird. Thank you very much for joining me today. I'm going to talk about where the world is headed in the world of blockchain, or DLTs. We have public ledgers, we have private ledgers. How are those two starting to converge and combine? And how are we getting the best of both worlds, public and private? So, how do we do that? Where are we headed? Well, a private network, of course, is a group of computers that are privately owned, they're privately held, not just anyone can put a computer in there, and they come to consensus on transactions. The users of a private network are only those that the private network allows. So it might not allow everyone to be a user. And the computers are, of course, only those that they allow for the private network. This is good because you can keep privacy. You can keep things secret. It is also good because it can be low cost. On the other hand, there are public networks. So in the public network, the users are in a sense outside the network. Anyone in the world can use it. Anyone in the world can see it. The network has no control over them. It is public. The computers are still inside the network, though often a public network allows people to join anonymously. But the computers are in the network, and the consensus is done by those computers. So these are the mainnet nodes, the full nodes of the system. And so the full nodes are running in the system, they are the network, but the users are outside. And so you can have great trust because the network can be bigger or can be running nodes that are more trusted, but you can also have transparency. Everything that happens is visible to the whole world. You can't keep any secrets. Everything is transparent. So those are public networks and private networks, public ledgers and private ledgers, DLTs, blockchains. In between, though, you might have appnets. So an appnet is an application network that combines the two. You still have the computers making up the network, the nodes in the network, the computers are inside of it, but the consensus is outside of it. The idea is that you're going to have someone with more trust and transparency doing the consensus, but you keep the actual processing inside the network. So what do you get? Well, you get the privacy and you get the low cost of a private network, but you get the trust and the transparency of a public network. And when I say transparency and privacy at the same time, you control that when you set it up. Maybe some things are completely secret and some things are completely public. And you can have both. You can have a combination of the two. You can have some things public and you have logging, and you have some things secret. This is what an appnet is. And the key idea is that it's like a private network that does your logic, but a public ledger that puts the transactions in order. And so you use the public for putting them in order and giving them timestamps, the private for actually doing the calculations, and gives you the best of both worlds. Now, that is what the consensus service that we do does in Hedera. It allows you to create appnets. A little bit different from a level 2, L2 approach, where there's a network on the side that does all the calculations, and then on rare occasions, it puts a summary into the main network, the public network. This is the opposite of that. Instead of having all these transactions on the side and then storing the answer on the main one, we're going to do it the other way around. We're going to have all the transactions flow through the main public network and store the information on the side. So how does that work? Well, it works like this. Here are 3 computers that are going to stand up the private appnet. Whereas on the right there, you see the Hedera public network. Hedera is an example here, but in general, you have a public network and an appnet. Then what happens is that the information is stored in the private, in the appnet. So for example, a stable coin, the balances of what all the users have of the stable coin, those are stored in the appnet. They are not stored on the public network. And so the appnet remembers what everyone's balance is. Or if you're playing a game, it remembers the state of the game. Or if you have tokenized assets, it remembers those. The information is stored in the appnet. Then When you want to do a transaction, to move a stable coin from one person to another, to play a move in the game, they send the messages to the main net, the public network, to Hedera in this case. And Hedera puts them in order. The public network that has the trust puts them in order, puts a proof that they are in order, and sends them back in order with timestamps, with a cryptographic proof that this is true, a state proof for us, to prove that this is real. And then the computer it sends it to can just pass it on to the others. They believe it because it has that proof signed by the mainnet. And you now have the AppNet having the information. And it is processed there in the AppNet. They now process what these transactions mean. And so they update the balances or whatever. And we can always check that they did the right thing by looking at what they've done and comparing to the ordered transactions from the mainnet, from the public network. And we can trust it because the public network gives us this cryptographic proof, this digitally signed state proof that says, yes, this truly was our consensus. And I said they were encrypted so you could have total privacy. The mainnet doesn't know who's transferring stable coins to whom, or who is playing what character in the game. It's all invisible to the mainnet if it's encrypted. Or you can make parts of it not be encrypted, and then you have a record being published to the world of what's going on. You can do it either way. So you can have privacy and you can have transparency at the same time on different parts of it. You can have low cost. You can have why is it low cost? All these computations are being done on the AppNet, not on the mainnet. All that's happening on the mainnet is a flow of transactions. So the mainnet has to be fast, but it doesn't have to do any calculations. It just needs to do consensus, and it needs to do it fast. So this gives us privacy, but it also gives us trust. It's the best of both worlds. That is why we have AppNets. This is the convergence of private and public. An AppNet is sort of in between. It's private and public at the same time. So why isn't everyone doing this? Well, I do think the world is headed this way. The advantages are just so great. And our users have been extremely excited about this year and have been using it a lot because it is a very good combination of properties. But you do need a mainnet that can do certain things. Your public network does have to be fast and trustworthy and able to connect. So in Hedera, we have a network. That's the circle at the bottom. It's the computers. Then we have the services that run on it, including the one on the right, the consensus service that we just talked about. And then you have all sorts of distributed applications on top of that, run by third parties. Wide range of those running on us right now. And then the end users use those. And we have a governing council in the lower left there that runs it all, that decides what features will go into the software and reviews the software and chooses what features there are, chooses the pricing, all of those things. And today they're even running the nodes, although we will progress to even have other people run the nodes. But the council builds in the trust. This is the mainnet. Because of the council, we have trust. And the council right now is 15 names. And they are names you've heard of, LG Electronics. All sorts of big names are making up our council. And they are not just advisors, they actually own it, they run it, they make the decisions. And these are all big names you know. So we have the trust part of this, but you also need speed. You can't really do AppNets if you don't have speed. You have to use L2 or something, layer 2, if you're slow. But if you're fast, you can do an AppNet. So we have all of these developers and applications, just a huge number. This is a tip of the iceberg. And we're doing more than 1 million transactions per day. I think it's about 1.5 million that we've averaged over the last 9 months. We've exceeded Ethereum. We're doing more per day than Ethereum. And these are real transactions from real users. These aren't test transactions. These aren't our transactions. These are real transactions from real users. So we're already exceeding Ethereum, but we can go much faster than that, almost 1 billion a day. With our current network, we have throttled it down to 0.8 billion. We will allow it to go faster in the future. But right now, we're making it slower, so it can only do this, which is far faster than what could be handled by other ones. So you do need this kind of speed if you're going to do an AppNet. If you're slow, you'll be forced to use L2. but layer 2. But if you're fast, you can do this kind of convergence of public and private. So there is another thing that is important here. And this is, if you want your AppNet to really be like a private network, you're going to be writing applications on it. This is complicated. How are you going to build your system? Anytime you write software, it's complicated. Even just writing a smart contract is complicated. What you want is an ecosystem of lots of tools to make this easy for you. For example, there's the Hyperledger Fabric ecosystem. All sorts of different open source companies working together, building tools to help you build Hyperledger Fabric networks, and to write the applications on them, and to store your data, and to do the identity, and to do the communication, and all of those things. Hyperledger Fabric does that for you. It lets you build a private network and then to manage it, to look at the computers and see which ones are turned on and which ones have crashed and what's going on and what's the usage of it right now. All of that. There's a whole huge ecosystem around Hyperledger Fabric. Similarly, there's a whole ecosystem around R3 Corda, another way of doing private networks, and a whole other one around Quorum. There are different ways of doing private networks. And Hedera is building plugins for these. So right now, you can build your Hyperledger Fabric network and then put in the little module at the bottom that connects it to Hedera. And you just flip a switch. Your network is now a Hedera AppNet. You didn't change any code. You didn't rearrange anything. You didn't change how it works. And it just works. So you can take any private network and flip a switch, and now it is an AppNet. It is a convergence of private and public, and you get all of the trust of Hedera, and you get the, you're using the speed of Hedera, and you're inheriting that into your private network. So this is how you can build it very easily. So what you want in the public network is you want speed, you want trust, and you want it to be easy to integrate. And so that's what we try to provide here. And above all those, really the speed is the most important one to make it work. But the trust is to make you want to do it in the first place. And the ease of use makes it worth doing. We have all those things. And those are important. And so what we see in the world is that public and private ledgers are merging, are combining. L2 solutions are one way to do it, where they're very separate and only occasionally talk. The opposite of that is the AppNet, that the consensus service that we're offering and that other people, I imagine, will offer, is allowing them to converge. But you do need a fast public network. For more information on our consensus service, you can just go to hedera.com/consensus service. And that it tells you how to use it and gives you example code and things. And so that's how you can do that. But the question then is, well, who is using it? What applications are running right now? What are use cases for this? And there's a lot. In fact, we have found people, we've been amazed at the excitement that our users have had over the AppNet since we brought out the consensus service early this year. And just in less than a year, the interest has exploded. And we have all these applications running on us now using our consensus service because AppNets are so compelling. So take Armada Chain. They're doing supply chain management using Hedera connected to an AppNet. And so Hedera puts the things in order, and the AppNet then gives you collaboration and supply chain management and tracking and auditing and all of those things. And you get the combination of the two. And Armada Chain is doing it right now on Hedera. Or take exchange markets. Nickel is Asia's first FX exchange on the blockchain. They are running on our AppNet. And they've talked about the tremendous value of combining the public network and the privacy of the permission network. It combines the two things. And so they have been very interested in having this combination, and they've used it for their exchange. Or take AdsDAX. They're doing audit logs, which is incredibly important in the advertising industry. And so they are a mediator in the advertising industry. They're the middleman between the advertisers and the people who want advertisements and the websites that provide advertisements. They're the middleman, they connect the two. And it's huge amounts of fraud in that industry, and they combat the fraud by putting everything in a publicly visible, auditable audit log in real time. Their advertisers can see it. The ones paying for the advertisement and the ones providing the advertisement, both sides can see it, and then the world as a whole can see it. CBDCs, central bank digital currency. There's a great deal of interest in having CBDCs. This is a coin, say, for the actual currency of a country, but you could use this kind of converged system to do a CBDC. You could also do purely private, but you get additional trust layers of having the combination. Or you could do purely public, but then the government wouldn't have as much control over it. And so really you get this sweet spot for a CBDC where there is a private network, where the government can control the private side, and then you have the trust and the widespread usage on the other side. So that is CBDCs as a use case, and there's a lot of people interested in that. Okay, so I thank you very much for your interest and for your time. Thank you very much, and I hope that this was somewhat helpful for you. Have a good day.